Alright, so a 600 Newton painter stands 2 meters from one end of an 8 meter long scaffold. If the scaffold is 800 newtons and a 500 Newton pile of paint cans is 2.3 meters from the other end, what force must be exerted on each end of the scaffold to support it? Now, the only tough thing about these problems is the bookkeeping, but this picture makes it pretty easy. So here we have the painter, the cans, and the scaffold weight, which is exerted in the center because it's uniform. Now, for this, we got to solve for each end. So we got to pick a pivot point, and it doesn't matter which one you pick. You can solve for either, but we'll pick A as our pivot point. And we use the formula that torque equals force times distance. So, if this is our pivot point, then we're solving for the force on B. So, because the scaffold is 8 meters long, 8 times the force is equal to, looking at the torque of everything on the scaffold, 500 for the paint cans times 2.3 because of its distance from the pivot point, plus 800, which is the force of the scaffold itself, which, because it's exerted at the center, we multiply that by 4 because the whole thing is 8 meters long, we divide by 2. And then the 600 Newton painter, who is 2 meters away from this end, but that means he's 6 meters away from this end. We always do it from the pivot point. Now we solve this for F, and we end up getting the force on B is equal to 993.75 newtons. And then we have to solve for the other end. Now there are different ways you can do this. Now for the other end you can do exactly what we did for B. Pick this as the pivot point and then do everything from this end. Exactly what we did here. But there is a shortcut. And that's just add up all the forces that are on the scaffold. So we have the 500 Newton paint cans, the 800 Newton scaffold, and 600 Newton painter. We add that up, we get 1900 newtons. To find force A, all we need to do is subtract force B. And that gives us, for force A, 906.25 newtons. And that's torque.